Okay, or if I'm going to use, okay, the usual way of writing your x and y axis, which is horizontal in the x-axis, and we have vertical in the y-axis. This is your y-axis. So we have, so this is the x-axis. And this one is now the y-axis. If you will going to take summation of forces, summation of forces along the x is equal to 0, to the right forces positive. So we have RC sine of 45 degrees. And then minus R1 sine of 45 degrees is equal to 0. So that your RC is equal to R1 sine of 45 degrees over sine of 45 degrees. So RC is equal to R1. Now, summation of forces along the y-axis is equal to 0, upward forces positive. So your RC cosine of 45 degrees plus R1 cosine of 45 degrees minus 1962 is equal to 0. So RC cosine of 45 degrees plus R1 cosine of 45 degrees is equal to 1962 newtons. Now, RC is equal to R1, or R1 is equal to RC. So we have RC cosine of 45 degrees plus R1 is equal to RC. RC cosine of 45 degrees is equal to 1962. Again, factor out RC. So we now have 2 cosine of 45 degrees. Cosine of 45 plus cosine of 45, 2 cosine of 45 degrees, that is 1962. So your RC is equal to 1962 all over 2 cosine of 45 degrees. So your RC is equal to 1387.344 newtons. So this time, R1 is equal to RC. R1 is equal to RC, hence your R1 is equal to 1387.344 newtons. Okay, let us try to draw now the reaction at contact point A and at contact point B. So let us try to draw the free body diagram of the lower pipe. So we have the weight of that pipe, and this is therefore the weight. So and your weight again in here is equal to 1962 newtons. Now, the reaction between the contact surfaces of the two pipes, which is R1. Okay, so R1 is making an angle of 45 degrees with the vertical. So this is now your R1. So your R1 therefore is now equal to 1387.344 newtons. 87.344 newtons. So we have computed that in the previous FBD. So this makes an angle of 45 degrees with the vertical. So that one is 45 degrees. And the reaction at contact point B, which is normal to the smooth surface. So the smooth surface in here is vertical, hence this one in here is horizontal. So that is normal to the smooth surface. This is therefore your RB. So we have your RB. And we now have the reaction at contact point A. So again, it is normal or perpendicular to the smooth surface. Hence, this is equal to, again, this is now your RC. And your RC again makes an angle of 45 degrees with the vertical. Okay, so same as what we did for the first FBD. So this one is 45 degrees. Now, knowing now the forces acting on the free body, the known forces and the unknown forces, let us apply now the equation of equilibrium. So apply the equations of equilibrium. Apply the equations of equilibrium. Now, I'm going to consider this one in here as the x-axis, and this one is the y-axis. Now, summation of forces along the y-axis is equal to 0. Again, I did consider y because if you try to take summation of forces along the y-axis, only RC is unknown because RC has component in the y-axis. RB is along the x-axis and therefore it has no y component. Summation of forces along the y is equal to 0. Again, upward forces positive. So RC cosine of 45 degrees minus R1, and R1 is 1387.344 newtons. So that is cosine of 45 degrees. And then minus W, 1962 newtons is equal to 0. So that your RC is cosine of 45 degrees is equal to 1387.344 cosine of 45 degrees plus 1962. Hence, the value of RC is now equal to 0.344 cosine of 45 plus 1962 divided by cosine of 45 degrees. So, the reaction at contact point, this is A. At contact point A, so that is your A, this is your A. So at contact point A is therefore equal to 4,162.031 newtons. Next, summation of forces along the X is equal to 0 to the right forces positive. Minus RB. Okay. Plus R1, and R1 is 1387.344 sine of 45 degrees. This is plus RA, and RA is now equal to 4162.031 newtons. That is plus RA, or that is 4162.031. That is sine of 45 degrees. And that one is equal to 0. So your RB is now equal to 3924. Transpose this to the other side of the equation, so positive. The sum of that is 3924 newtons. So that is the contact reaction at point B. Now, you try to take note in here now that we cannot apply your force triangle because there are 4 forces in the free body diagram, or acting on the free body diagram of the lower pipe.